Now that we're familiar with the Pythagorean theorem, we're going to look at a set of triples that follow the Pythagorean theorem every time. Pythagorean triple are a set of any three whole numbers that satisfy the Pythagorean theorem equation. The first family of triples would be the 3, 4, 5 family. So I have a drawing of the 3, 4, 5 family on the right triangle, and that family includes sets of numbers such as these. Let's double each number. So we would get 6, 8, and 10. That's in the 3, 4, 5 family. In addition to multiplying by 2, we could multiply by 3. So take 3, 4, and 5 and multiply by 3. You'll get 9, 12, 15. Or multiply by 4. You'll get 12, 16, 20. And I'll multiply by 5, 15, 20, 25. So if you see two of these sides on a triangle, you can conclude what the third side would be. For example, if you are given a triangle and the longest side is 20 and one of the shorter sides is 12, well, that is in the 3, 4, 5 family. You might try to investigate if you're not sure. What I mean is the numbers 12 and 20 have a common factor of 4. So like you can rewrite 12 as 4 times 3, and you can rewrite 20 as 4 times 5. See, they both have a 4 as a factor. But then look at the other number. This one has a 5, and this one has a 3. That's the 3 and the 5 from the family 3, 4, 5. So that means the missing side is actually 4 times 4, which is 16. Our next family is the 5, 12, 13. Other sets of numbers that are in the family are 10, 24, 26, and 15, 36, 39. And then I'll multiply by 4. 5 times 4 is 20, 12 times 4 is 48, and 13 times 4 is 52. So there's an infinite number of these sets of numbers, but these are the ones that show up very frequently for us. One more. There's a family called the 8, 15, 17. Now I've drawn a triangle here with an 8, 15, and 17 on it, and I multiplied each side by the square root of 2. So officially this isn't a Pythagorean triple because these are not whole numbers up here. But you can see how someone can take the Pythagorean triple 8, 15, 17 and multiply each side by the same factor, and then you get a triangle that's a right triangle. Other members of the family include 16, 30, 34, and I'll multiply by 3. So I'll get 24, 45, and 51. So you may see these. Please notice that every time I set up a Pythagorean triple here, the longest side should be the hypotenuse. So if I go back over here to the 5, 12, 13 for a moment, if you are given a right triangle and it has a 5 and a 12 in it, so here's a 5. If they put the 12 on the hypotenuse, then it's not this Pythagorean triple. They need to put the 12 on the leg because the first two numbers are shorter. They belong on the legs. 13 would belong on the hypotenuse. So we'll get a couple of examples where they will not be Pythagorean triples, so keep a lookout for that. By the way, there are an infinitely many number of families. 7, 24, 25 will be in our work. You might see a 9, 40, 41, and 11, 60, 61. So those are some more triple families that you might see. Starting with number 1. Before, we would do Pythagorean theorem on this, but I don't need to. I'm noticing that 10 and 24 are both even numbers, so they both contain a factor of 2. Look at the factors for a moment. 2 times 5 and 2 times 12. Okay, I'm pulling out the same factor. I'm pulling out the 2. What's left behind? There's a 5 and there's a 12. Is there a family that has a 5 and a 12 on the legs? Yes, there is. The 5, 12, 13 is that family. If one leg we got by having 2 times 5 and the next leg was 2 times 12, that means the hypotenuse would be 2 times 13 or 26. So your answer to number 1, 26. Number 2, Instead of doing Pythagorean theorem, I'm going to observe both of these numbers have factors of 2. So 16 is 2 times 8, and 34 is 2 times 17. So they both have the factor of 2 in common. Now look at the other factor. This one is an 8 on the leg and a 17 on the hypotenuse. That is from the family 8, 15, 17. If one leg is 2 times 8, the other leg would be 2 times 15, 30. Number 3, do 75 and 21 have a common factor? The number 3 goes into both of them evenly. 21 is 3 times 7. 75 is 3 times 25. Both have a factor of 3 in common. Now look at the other factor. The hypotenuse has a 25 as a factor, and a leg has a 7. That actually comes from this family down here, listed below. It's the 7, 24, 25. So this is the family 7, 24, 25 that we are seeing in this right triangle. If the leg is 3 times 7 and the hypotenuse is 3 times 25, then the other leg is 3 times 24, which is the same as 72. So the answer to number 3 is 72. Number 4, here's a new approach. Instead of finding a common factor, I'm noticing that these numbers, they're kind of small, and one of them is 1.5. So it's like somebody took 3 and divided it in half. 3 divided by 2 is 1.5. What number divided by 2 gives you 2? That would be 4. So 4 divided by 2 gets you 2, and 3 divided by 2 gets you 1.5. So they both are being divided by 2. Now look at the other number, the one in the numerator. A 3, a 4. So what family is this from? The 3, 4, 5 family. So if a leg is 3 divided by 2, a leg is 4 divided by 2, that means the hypotenuse is 5 divided by 2. You can leave it 5 divided by 2, or you can write 2.5. Number 5, why don't you try this one yourself? So turn off the video and come back on to check your answer. 2.5 is the same as 5 divided by 2. So let's rewrite this one as a number divided by 2. What number divided by 2 is 6? That would be 12. So now I'm going to look at those numbers on the top. 5, 12. What would be the third number? What family is this from? The 5, 12, 13. So 5 divided by 2, 12 divided by 2, and 13 divided by 2. You can leave it as 13 divided by 2, or you can write it as 6.5. What do you think is number 6? I see a 3 and a 4. Does that mean a 5 goes here for the 3, 4, 5 family? No. In order for this to be from the 3, 4, 5 family, the 5 would have to be on the hypotenuse. This is not a Pythagorean triple. When that happens, you have to use Pythagorean theorem. So the missing leg, I'll call it A. So I'm going to have to do A squared plus 3 squared equals 4 squared. A is the square root of 7. Number 7. I realize these sides of 3 root 2 and 4 root 2 are not whole numbers, but I'm playing on the notion that there's a factor of 3 and a factor of 4. So the hypotenuse would have a factor of 5, and each side was getting multiplied by root 2. So the missing side is 5 root 2. Number 8. Try number 8, turn off the video, and then come back to see the answer. Okay, both numbers are divisible by 2. 24 is 2 times 12, and 26 is 2 times 13. Look at these other factors, not the 2's, but the other factors. We have a 12 and a 13. This is from the family 5, 12, 13. That means the other leg is 2 times 5, or 10. Okay, try number 9. Turn off the video and come back on to check. Number 9. 9 is 3 times 3. 15 is 3 times 5. So look at the other factor, a 3 and a 5. That means I have a triangle from the 3, 4, 5 family. The 5 is on the hypotenuse, the 3 is on a leg. So the missing side is 3 times 4, which is 12. Go ahead and try number 10 and then turn the video back on to see the answer. Is this a triangle from the 5, 12, 13 family? No, the 12 is on the hypotenuse. The 13 is supposed to be on the hypotenuse, not the 12. You're going to have to use Pythagorean theorem to solve for the missing side. A squared plus 5 squared equals 12 squared. The answer is the square root of 119. Try the last two problems, so turn off the video and come back on when you are done. In number 11, you can write 15 as 5 times 3. You can write 20 as 5 times 4. So the numbers I'm looking at are the 3 and the 4. Is this from the 3, 4, 5 family? No. If it was, then the 4 would be on the leg. So you have to use Pythagorean theorem to solve this. The answer to number 11 is 5 root 7. In number 12, 7½ is 15 divided by 2. So if I do the same thing to 4, 4 is the same as 8 divided by 2. So I'm going to look at the 8 and I'm going to look at the 15. This is from the family 8, 15, 17. The hypotenuse then would be 17 divided by 2. And you can circle that, or you can write it as a decimal, 8½